25 is a mixture of gases problem. We're told that we collect hydrogen gas over water at 20 degrees and we get a pressure, total pressure of 757 torr. The volume is given as 35.3 milliliters, so I changed that into liters. Now, since it's a mixture of gases, it's important that I look up the vapor pressure of water at 20 degrees, and that's the partial pressure of H2O at 20 degrees, and that equals 17.54 torr. So from this I can determine that my pressure of my pressure of hydrogen is going to equal the total pressure, 757, minus the pressure that comes from the water vapor that was trapped with it. So my pressure for just the dry hydrogen gas is 739.46 torr. Now, I'm supposed to determine what volume would this dry gas occupy at STP. So this becomes a combined gas law problem, where I've got my pressure 1, pressure 2. Pressure 1 is this dry gas, 739.46. Pressure 2 is at STP, that's 760. I've got temperature 1 and temperature 2. My temperature 1 is 20 plus 273, that's 293 Kelvin. Temperature 2 is STP, standard temperature is 273 Kelvin. And I get my volume 1 and my volume 2, and my volume 2 is what I'm going to be looking for. Volume 1 is 0.0353 liters. So to find the volume at STP, all I need to do is use the combined gas law. And remember, it is given to you as P1 V1 over T1 equals P2 V2 over T2. But if you remember that it is easier to manipulate it if you look at it this way, P1 V1 T2 equals P2 V2 T1. All I did was I multiplied the denominators across to the other side. And since I'm looking for V2, this makes it easy because all I have to do is move P2 and T1 onto the denominator on this side. So V2 ends up being equal to P1 V1 T2 all over P2 T1. Well, I have all these numbers, so it's just time to substitute it in. V2 is going to equal 739.46 times 0.0353 liters times T2, 273. That whole thing is going to be divided by pressure 2, 760, times temperature 1, which was 293. So, substitute those in, get out the calculator, and we find that it is 32.0 milliliters.